Today, we're going to try and map the entire world of data analytics. It can feel like this massive, chaotic universe, right? But what if? What if we could organize it all like a genome? A family tree that shows exactly how every little piece is connected, from the biggest branches all the way down to the individual genes. Let's start sequencing.
So first, let me ask you a question. When you hear that phrase, data analytics, what do you picture? Is it just one single giant field? A lot of people see it that way, but honestly, that's not really the whole story. Because in reality, it's much more like this. A huge, sprawling family tree with deep roots, all these major branches, and literally thousands of tiny interconnected parts that all share some common ancestry. And trust me, when you start to see it this way, everything changes.
Okay, so for our first section, let's actually start building this family tree out. You're about to see how this one simple metaphor can make a super complex subject feel way more structured and, just manageable.
Every big family has its major clans, right? Well, in our analytics genome, one of the biggest is risk analytics. Just think of this as one of the main branches of the whole tree. It deals with pretty much everything from financial risk all the way to operational risk. It's a big one.
All right, let's move on to section 2. Now we're going to zoom in from that main branch and actually meet a few of the family members. This is where we get to see what these different analytics capabilities really do.
Here's a perfect example from that risk analytics clan we just mentioned, health and safety risk analytics. It's a specialized skill set that does exactly what it sounds like. It uses data to help keep people safe while they're at work.
And this capability has its own little offspring, all these specific tools. And look at the range we've got here. You have pretty straightforward things like an incident rate calculator that just tracks what's already happened. But then you get these really sophisticated, forward-looking tools like a predictive risk modeler, or even a fatigue and burnout risk modeler. Each one is a totally unique tool for a very, very specific job.
So, here's the bottom line. All those technical names, they all boil down to one simple, incredibly powerful outcome: predicting and preventing accidents before they can even happen.
Now, just to show you how this structure works everywhere, let's jump over to a completely different part of the family tree. Over in the employee analytics branch, we find something called training effectiveness analysis. And its whole job is to answer one simple question: does our training actually work?
And yep, here are its offspring. You can see standard stuff in here, like frameworks from the Kirkpatrick model that measure effectiveness on different levels, but you also find these incredibly specific tools like a scrap learning estimator. Think about that. That's a tool designed for one reason: to figure out how much of your training budget is just being wasted on stuff that people forget or never even use.
And this is why it's so brilliant. This whole set of tools answers a critical question for any business. Are the millions of dollars we're spending on training our people actually making any difference to their performance? Okay, this brings us to what is maybe the most important insight of this whole map. In section 3, we're going to start looking for the common DNA, the stuff that connects all these families that seem so different on the surface. Just take a look at this. On this slide, we're comparing 3 different analytics families: health and safety, training, and financial. See what's happening? They're all built from these shared components, like a common set of genes. A root cause analysis engine, that's super useful for figuring out why accidents happen, but it's also useful for figuring out why a budget is way off. A dashboard unit, well, everybody needs one of those. These tools aren't built from scratch every single time. They're assembled from the same core parts. So the huge lesson here is this: data analytics isn't about thousands of unique, magical black boxes. It's a system of interchangeable, fundamental building blocks. It's like Legos. But while this whole genome was being mapped, something really fascinating popped up: a mysterious gene that seems to appear everywhere. So in section 4, we're going to investigate what's being called the quantum governance gene. Seriously, across hundreds and hundreds of different capabilities, one single component, one gene, showed up in every single one, no exceptions. Any guesses what it might be? The answer is a component called quantum function governance, and in this mapping system, it shows up as the 26th component in every single family, without fail. Okay, now you can't go out and buy this today. This is more like a conceptual blueprint for the future. The quantum part here isn't about quantum computing. It's about the idea that governance has to happen at the smallest possible level, at the level of every single function. Think of it like a universal safety switch and an ethical compass that's built right into every analytic component. As these AI-powered systems get more and more autonomous, this gene is what makes sure every single action, no matter how small, is secure, ethical, and doing exactly what it's supposed to.
So, what do we do with all this? In our final section, let's look at how this family tree becomes a practical, usable map for solving real-world problems.
It's really just a simple three-step process. First, you start with a clear goal. Something like, I need to improve my employee training. Okay? Second, you find that topic on the map. In this case, you'd go to the employee analytics branch. And third, the map shows you the exact building blocks, the specific components you'll need to put together to actually solve that problem.
And that's really the power of the analytics genome. It takes this giant, scary list of technologies and turns it into a clear, structured map that pretty much anyone can use to find their way around the field and build what they need.
So we've walked through the family tree, we've spotted the common DNA, and we've shown you how to read the map. The only question left is the one that really matters. Now that you have it, what problem are you going to solve first?